Section 14.5 is on subtracting rational expressions. So to subtract when the denominators are the same, we just subtract the numerators and keep the same denominator, and then simplify if possible. So 8 over x minus 3 over x. Since we have the same denominator, we're just going to subtract the numerators. So 8 minus 3 all over x. And so we end up just getting 5 over x. Same idea goes for the second one. The only thing you need to be careful of is that you distribute this negative to both of the pieces in the second numerator. So the first one is going to be the same, but you're subtracting the entire numerator of the second fraction. This is still over the same denominator, x plus 2. And so we need to make sure we distribute, and we'll get negative x plus 2 all over x plus 2. And we can combine like terms. We have 3x and negative x. And that will give me 2x plus 2 all over x plus 2. And the only thing we can do is we can take a common factor of 2 out, and we get x plus 2 times x plus 1 over x plus 2. And that's your final answer. So the trickiest part of subtraction is making sure you distribute the negative to all the pieces in the following fractions. So when we have different denominators, first we need to find the LCM of the denominators, which becomes the LCD, and then we're going to make an equivalent expression with the LCD, just like what we did with addition, except we need to have the subtraction. That's the only thing that changes. The rest of it's the same exact thing. So here I've got x plus 2 over x minus 4 minus x plus 1 over x plus 4. So first is to find the LCD. In this case, I need to have the x minus 4 and I need to have the x plus 4 present. And so in the first one I have x plus 2 all over x minus 4, and the piece I'm missing from the LCD is x plus 4. And so what I do to the bottom, I have to do to the top. In the second one, I have x plus 1 all over x plus 4. And the piece I'm missing from the LCD in this case is the x minus 4. And so what I do to the bottom, I have to do to the top. What we want to do first, though, is we want to FOIL the numerators. So we end up getting x squared plus 4x plus 2x plus 8. Go ahead and bring the subtraction sign, but put a set of parentheses to FOIL first. And we get x squared minus 4x plus x minus 4. And this whole thing is all over the LCD. And so we need to distribute this negative to all the pieces in the parenthesis. So the first part's going to stay the same. And we're going to get minus x squared plus 4x minus x and plus 4 all over the LCD. And the last thing we want to do is combine like terms and simplify. So I have x squared and negative x squared, and so those end up canceling. I have 4x and 2x, which is 6x, plus 4x, which is 10x, minus x, which is 9x. And I have 8 and 4, which gives me 12, all over the LCD. And the only thing I can really do here is pull out a 3 as our GCF, and we're left with 3x plus 4 all over the LCD. And so it works exactly the same way as the addition did. The only thing that changes is you have to be very careful with that negative. So let's go ahead and try another one. The first thing we need to do is we need to factor the denominators to find the LCD. So x squared plus 5x plus 6 factors is x plus 2 and x plus 3. And x squared plus 3x plus 2 factors is x plus 1 and x plus 2. And so my LCD in this case is going to be x plus 2, x plus 3, and x plus 1. So let's go ahead and write them over again, but with the factored denominators. So the first one's going to be over x plus 2 and x plus 3. And the piece I'm missing from the LCD is x plus 1. And what I do to the bottom, I have to do to the top. Same idea goes for the second one. We have 2 over and then in factored form, we've got x plus 1 and x plus 2. And so the piece that I'm missing from this one is x plus 3. And what I do to the bottom, I have to do to the top. And so let's go ahead and distribute the x in the first numerator. That's x squared plus x. We have that subtraction sign, and we want to distribute the 2. And so we end up with 2x plus 6 all over our LCD. And so what we want to do is we want to distribute the negative. And so we end up with x squared plus x minus 2x minus 6 all over our LCD. And so we can combine like terms. I've got x and negative 2x. So we got x squared minus x minus 6 all over our LCD. And we want to see if we can factor the numerator, which we can. That's going to factor as x minus 3 and x plus 2. And so we can end up simplifying. Because we have an x plus 2 on top and on bottom. And so we end up with x minus 3 all over x plus 1 times x plus 3. What about denominators that are opposites? This works the same way. We want to make sure we multiply one of the fractions by -1 over -1. So in example 3a, I have a 5 and a -5. And so I'm going to keep the first fraction the same, and I'll manipulate the second fraction by multiplying by a -1 on the top and bottom. And so rewriting, the first one's going to stay the same. And we're going to distribute the -1 on top. That's a -3x plus 4 all over 5. And so because I have the same denominator, I can combine the top. So that's x minus -3x plus 4 all over 5. And we just want to make sure that we distribute the negative to both pieces. And so we get x plus 3x minus 4 all over 5. And the last step is to combine like terms. I've got x and 3x, which gives me 4x minus 4 all over 5. And we could take a GCF out of 4. We have x minus 1 left over all over 5. Let's go ahead and try the second one. I'm going to manipulate the second fraction by that -1 over -1. So this first one is going to stay exactly the same. And then I'm going to multiply the top and bottom of the second fraction by -1. And so the first one doesn't change. And the second one, we end up with -2y plus 3 all over. This becomes y minus 5. And then because we have the same denominator, we're just going to combine it into one fraction. And we just want to make sure we distribute this negative to both pieces. So we end up with 5y plus 2y minus 3 all over y minus 5. And combining like terms, we end up with 7y minus 3 all over y minus 5. Same idea goes for factors that are opposites. So we always want to make sure we factor to find the LCD. And if we do have opposites, we can multiply by that -1 over -1. So looking at p over 64 minus p squared minus 5 over p minus 8, let's go ahead and factor the denominators first. So we have p over, this is a difference of squares, and it becomes 8 minus p and 8 plus p minus 5 over, we can't do too much with the p minus 8, and so we need to find the LCD. So if we notice, 8 minus p and p minus 8 are opposites. So I am going to multiply this second fraction by -1 on the top and bottom. And so what we end up getting is p over 8 minus p times 8 plus p minus, we've got a -5 on top, and then that negative is going to turn this into 8 minus p. And so our LCD is going to become 8 minus p and 8 plus p. And so the first fraction has the exact same denominator, so we don't have to fix it at all. But the second fraction we get to multiply by the 8 plus p that we're missing. And so we're just going to rewrite the first fraction. And then the second fraction, we're going to distribute the -5. So we get -40 minus 5p all over the LCD. And because we have the same exact denominator, we can combine the tops. So we have p minus -40 minus 5p all over the LCD. And then we just want to make sure we distribute this negative. And so we end up with p plus 40 plus 5p all over our LCD. And then combining like terms, we have p and 5p, which is 6p plus 40 all over our LCD. And I think the only thing you can do on the top is take out a GCF of 2, then you're left with 3p plus 20 all over your LCD. And the last example is just combining addition and subtraction. So looking at the denominators, we can find our LCD pretty easy here. So we have an x and an x plus 1. The x's highest power that's present is a squared. And then we're going to have x plus 1 involved with the LCD. And so that's what we need to have for each one. So let's go ahead and write 1 over x and then figure out what I need to multiply the denominator by. Well, in this case, I'm missing one more x to get the x squared, and I'm missing the x plus 1. And so I need to multiply the top and bottom by x and x plus 1. In the second fraction, I already have the x squared, and so the piece that I'm missing is just the x plus 1. In the third fraction, I have the x plus 1, but what I'm missing is the x squared. And so I'm going to multiply the top and bottom by x squared. And so let's simplify this a little bit. The first fraction is going to become x squared plus x. And then I have the minus x plus 1 and plus 2x squared. And this whole thing is all over your LCD. So let's go ahead and distribute this negative before we combine like terms. So I have x squared plus x minus x minus 1 plus 2x squared. And that's all over the LCD. And so we can combine like terms. I have x squared and 2x squared. I have x and negative x, and so actually these two are going to cancel. And then I just have a lonely negative 1 here. And so what I end up getting is 3x squared minus 1 all over x squared times x plus 1.